Okay. Well, if you're going to do that, a lot of you started the curve here. So if you start the curve here and move left to right, it's going to have to go through this point before it gets to this one, right? And then it's going to get to this one. So it's going to have to come up here and then down here and then back up. Okay? And it's not going to peak here. It's almost certainly not going to peak at this point because of the way these numbers multiply out. So don't even try to make it peak here. I mean, if you do make it peak there, well, it's going to be a little misleading, but it won't be tragic. Okay? But there's no reason it should peak here. I mean, for example, this point's not even halfway between these two. And even if it was halfway between these two, you got three numbers to multiply here. It's not like a quadratic, so it probably is going to peak at the halfway point. Okay, then it's going to come on down here. And that's the way the graph's going to look. Now, how do I know that it doesn't level off here or something? Well, it's because these numbers all keep getting bigger, right? Okay? If x is to the right of 3, every one of these numbers is positive, okay? Because if x is bigger than 3, then x minus 3 is bigger than 0, right? Subtract 3 from anything bigger than 3, you're going to get a positive number, right? Add 2 to any number bigger than 3, well, it's clearly going to be positive. Subtract 1 from any number bigger than 3, it's going to be positive. And the bigger x gets, the bigger each of these numbers gets. So you multiply three numbers that keep getting bigger and bigger. Things are going to get bigger and bigger this way, and they're going to get bigger and bigger faster. Okay? So this is going to go up, and it's actually going to keep getting steeper. But it's not going to have an asymptote, because no matter how big the number is, you can calculate this. Okay? And it's going to be bigger than it was before. On the other side of -2, all these numbers are going to be negative. Okay? Because if you subtract 3 from a number less than -2, well, it's the negative minus negative, that's going to make it negative. If x is less than -2 and you add it to 2, it's still going to be negative. And if you subtract 1 from a number to the left of -2, it's going to be negative. Okay? So, there are things that we can say about the way these numbers work. Okay, to the right of x equals 3, so from here on, I'm going to write this out in more detail than I usually do. Okay, from what I said, any number bigger than 3 is going to make each of these positive, right? So you have a positive, multiplied by a positive, multiplied by a positive, which is positive. Okay? Over here on the left, each of these numbers is negative. Between -2 and 1, if the graph is drawn right, well, it looks like the y value should always be positive, right? Always above the x-axis. And we can confirm that because between here and here, if x is between -2 and 1, x minus 3 is still negative, right? Because in order for x minus 3 to be positive, x has to be at least 3. And none of these numbers are at least 3. So I can say that in here, x minus 3 has to be negative. What about x plus 2? Well, -2 plus 2 would be 0, right? Any number bigger than -2 is going to make this positive, right? Okay, so this is going to be positive. And x minus 1 is going to be negative. Because in order to make x plus 1 positive, x has to be at least 1. And x is not, x is less than 1 from all the way between here and here. So we have this. And a negative times a positive times a negative is positive. Over here, 3 negatives multiplied together give you a negative. Okay? Between 1 and 3, x minus 3 is going to be negative, because in order for x minus 3 to be positive, x has to be bigger than 3. So we got x minus 3, x plus 2, and x minus 1. This is negative. X plus 2, well, x is always positive between here and here, so when you add 2, it's going to be positive. X minus 1, well, for x to be positive, x has to be at least 1, right? Well, x is at least 1 from here to here, in between the zeros. So this is positive, which makes this negative. And that confirms, at least, that the signs of the graph are correct. Okay? Now, if we have another expression, okay? You can quickly determine that this is going to be 0. If x is -2 or -6 or 5, and plugging in x equals 0 to find the y-intercept, you get -5 times 6 times 2. Well, that's -60. So now we have -60 here. To the right of x equals 5, I'm not going to write out the expressions, but if x is bigger than 5, then x minus 5 is bigger than 0, right?
Right. Positive.
It's positive. And this is positive, and this is positive. Okay? Well, I'm not going to write out all this. I'm just going to write out that, okay, well, we have positive, 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 and that equals positive. Okay? Over here to the left of -6, well, x is a negative number, okay? And it's less than -6, it could be -7, -8, whatever, just take -7. If x was -7, well, this would clearly be negative, because it's running negative. -7 and 6 would be negative. -7 and 2 would be negative. Any number less than -6 makes all three of these negative. So we've got three negatives, that equals negative. Okay? Now, between -6 and 2, well, x minus 5 is clearly going to be negative because all these numbers are negative, and add two negatives, you're going to get a negative. So, what color am I using there?
Yellow.
Yeah, well, okay. Meant to use yellow there, but it doesn't really matter. Okay, between here and here, x minus 5 is clearly going to be negative. What about x plus 6? Okay, if I had a number between here and here to 6, positive or negative? Positive. Because x is bigger than 6 for all these numbers, or bigger than -6. So that's going to make this positive. Okay? Negative, it's positive. And x plus 2 is going to be negative because these are all negative numbers, less than -2. So like -3, -3 and 2 would give you negative numbers. So we're going to be positive here. And then between here and here, x minus 5 is still going to be negative because x has to be at least 5 to make this positive. So we're going to have a negative. But x plus 6 is going to be positive because 6 is big enough to make any of these numbers positive. And x plus 2 is going to be positive. You can figure that out. Just think about how the numbers are. So it's negative here. So when we draw the graph, it's got to go through here, so it's going to be negative from here to here, and it's got to go through this point, so that works, right? So we know we're going to have something like this. Between here and here, it's positive. Well, we can do that. It'll come around here and go down here. And then from here on, it's going to be negative, and it's going to get steeper and steeper. And from here on, it's going to be positive, and it's going to get steeper and steeper. So the graph's going to look like this. Make sense? Just work it. If you don't understand it, go back and watch the video. I said everything. It's there. Take notes. Step by step. Don't try to watch the whole thing and understand it. One step at a time. If you don't understand why I got a negative here, go back and listen again. Or go back and try your own numbers. Okay? Now another thing is, it turns out that all you have to do is take one number in any one of these intervals and plug it in, and you find out whether it's positive or negative. Okay? So for this interval, I could have picked -4, okay? Or -3 or -5. Or I could pick -pi. But you don't want to do that because pi is too hard to calculate with, okay? You can just use common sense, which is what I did there, and what I did originally. But if common sense doesn't work for you, you can pick a number, any number at all, in any one of these intervals and determine whether it's positive or negative. Why is that? Because the graph has to be a smooth curve, and it can't go through the x-axis, which means it can't change sign, because the only way it can change sign is to go through the x-axis, right? The only way it goes from positive to negative or negative to positive is for the graph to go through the axis. Okay? So you can gain all kinds of information about these graphs just with this simple reasoning, once you have a polynomial in factored form. Okay? And since you can almost never factor a polynomial, okay? Yeah, the polynomial comes at you from the real world, forget it. It's not going to factor. Very seldom. You know, you're kind of left with other methods, but you still want to understand what the graph of the polynomial can look like, and that's why we do this. Okay? Now, there are other things that can happen. So let's do the same thing with this polynomial. Okay? What happens to this polynomial? Go ahead and do what we just did. In other words, find its zeros. And the y-intercept. And then test each interval for plus or minus. Okay? Now do what we just did for this thing. See what you get.